one or two that the accuracy assessment part was not clear. I will explain a little bit of it again. Other than that, any doubts or any questions in your mind? Okay. Uh, just to know better, I want to ask you, are there any topics that you have in your mind that you want to be, though we are going with the curriculum, but I just want to understand, like, maybe there is something left and that's not covered in the curriculum. Maybe there is some topic that you know of. You can let me know in the chat, or maybe you can drop me a message on the WhatsApp also. So I will look into it, and maybe if it's in the scope of this track, I can try to cover it also. Okay. Uh, so yesterday, I got a doubt that I want to explain this part again. Just imagine that you took a image. So this was your image. You did supervised classification on it, and now it looks like this. Okay. So what it means is, if you see, we have divided it into four classes. You could have given more classes, but I have divided it into four classes. So maybe there is an object in here that was not among these four classes, but we have forced it to be classified into these four only. Okay. For example, there was maybe a muddy land or something, a well, or maybe anything. So, for example, in my field, in my classes, there is no barren land. Okay. So, if you maybe look in this part, this is barren land. Okay. But in this image, it has been classified as shrubland because I did not make a class of it. So, what happens is, just try to think that you have some number of classes that you defined, because in supervised classification you are guiding the computer what to do. Okay. So maybe it's supervised or unsupervised. Maybe it is supervised or unsupervised. In both cases, uh, but mostly for supervised, we create this confusion matrix. Okay. So there is something called as confusion matrix. What this matrix is about, you place the classes, that is, I have divided the image into these four classes. Okay. Sorry, three classes. Here there are three classes maybe. This is just an example. So maybe instead of four, if I would have divided the image into three classes, that is forest, water, and urban. Now, how to create a confusion matrix? One thing is you will tell the software to create it. One thing is you can create it. And the important part is to understand what a confusion matrix is. Okay. So, on the column side of it, it is something that is being represented on the map. On the column side of it, we write something that is being represented on the map. And on the up side of it, we write something that is actually on ground. So what it means is, if you look at the example of water, so just at the most right corner, there is the total number of pixels. So just imagine there is an image which has 125 pixels in it in total. So the complete image is 125 pixels. Okay. Now you have divided it into three classes. Okay. Now, what I mean, I'm taking an example of water map. So what it means is, after my classification, the number of pixels that were assigned to water is 35. So I told you maybe the object was something different on ground, but we have forced it to be something else also sometimes, right? So it can be more than actual number what it is on ground. So it can be more or less, right? So on the row side end of it against water map, this is the number of pixels of water in this image. So in this image, there are 35 pixels in total that represent water. Now, when you look on the water here, so because this was a classified image, right? This is after supervised classification. We are calling that supervised image as map, just for reference. Okay. Now, you take the original image of Earth, that is true color. So, in true color image, in actual, there were 40 pixels that belonged to water. But in my map, only 35 came up. That means 5 pixels were wrongly classified. They might have been classified as forest or maybe urban. But the scenario is there should have been 40 pixels, but we classified only 35 for water. This is one thing. Okay. The second thing is, similarly, we have the, maybe let us first say the example of urban map. So urban, by urban means built up area. Okay. So according to this, there are, for the classified map has 40 pixels of urban area. But whereas on the true image, we have only 35 pixels. So that means 5 more pixels have been added to it, right? That is probably the wrong classification. So this confusion matrix is to remove your confusion about the real data, that is ground truth, versus the data that we have created in the uh, classified image. Okay. Then the other part is this central diagonal values, these values. Now, what do these values represent? Because it is at a common junction of both the names. So it is the actual number of pixels that have been accurately classified as the class. So 40 number of pixels from forest have been rightly corrected as forest on map only. Okay. So in true image, if there were total 50 number of forest pixels. Okay. So total was 50 number of forest pixels. Out of this 40 pixels, have been correctly classified in this map. So this is the correct correct ones. Got it? I hope this part is clear. Um, any doubts in this? Okay. So then there are two terms, something called as producer's accuracy, something called as user's accuracy. Now, there is the meaning that you need to understand better, that why is it called producer's accuracy and why this is called as user's accuracy. Okay. So let me first talk about producer's accuracy and I will take the example of water. So if I take the example of water, what it says is the correct number of pixels by the total value in the column data. Now it means for water the correct number of pixels was 30, right? If you see this, 30 pixels were correctly marked. So 30 divided by the column total. So if you see this column, it says 50. What 50 means is it is the actual number of pixels in the true image, right? Actual number of pixels in the true image. So it is 30 by 50. Whereas if I talk about user's accuracy, user's accuracy is correct number of pixels, that is 30, divided by the row total. So for water map it is 35. So 30 by 35. Now if you see in here, we have used the map total. Now what that means is the pixels of map. So it is called user's accuracy because you are putting the correct number of pixels against a classified image that you created. So this image, this map was created by you. So the number of pixels representing water in that is 35. So because of your training samples, this got created, right? This 35 figure came out because of what you did in the training sample, right? So that is why it is called as user's accuracy because it is the pixels, total number of pixels in the map or classified image. Whereas for producer's accuracy, so you were able to see 30 number of pixels were correct. And this is the actual product on ground, right? Actual product. So according to the actual product, out of the 50 pixels, you have 30 pixels right. So that is producer's accuracy. If you have gotten 40 pixels right, so it means your producer's accuracy is high. Okay. So the accuracy, that is 40 by 50, it is multiplied by 100 to get the percentage. Similarly, user's accuracy, is taken in a same way. Now this is 30 by 35, that is 85.7. So any doubt in producer's accuracy and user's accuracy? Otherwise, please write all okay. Any doubts here? If still not clear, just let me know. Or is it clear? Okay. Now, there is something called as overall accuracy. So, what is overall accuracy? It is all the correct pixels. So, all the correct pixels are these diagonal ones, right? So, it is the sum of the diagonal 40 plus 30 plus 28 by the total number of pixels. So, 40 plus 30 plus 28 by 125. Our image had 125 pixels, right? So, that means your 98 pixels were correctly classified out of this 125. So that is 78.4, right? Then there is something called as kappa coefficient. Now, uh, how do we define kappa? Okay. So to understand kappa, you have to understand there is one more term that is called as expected accuracy. Okay. That is called chance agreement. It is a little mathematical to understand. It is based on probabilities. Okay. So to understand kappa, just look here. The formula of chance agreement. Okay. If you see here, so this is the, let us take the example of water only. So this is the actual number of pixels of water on ground. So that is 40 divided by 125. Okay. So if you know about probability, so try to understand these 40 pixels can be any pixels out of these 125. So this is a probability division. Okay. Now there is for the water only, we have 35 on the map. Now for the map, we have 35 out of 125. So in probability, there is something called as chance agreement. So we multiply them both. So that is the row total, sorry, column total into the row total by the square of the total number of pixels. So now you know how this formula came. And for forest, you know the chance agreement. Similarly for water, similarly for urban. Okay. So the total value of chance agreement is the sum of it. Sum of this three for all the classes. Now, kappa formula is observed accuracy minus this expected accuracy divided by 1 minus this expected accuracy. So observed accuracy you had 74. If this is, if you convert it from percentage to, this will become 0.784. Okay. So 0.784 minus this uh, chance agreement, that is expected accuracy, divided by 1 minus again the expected accuracy, and then you have a final figure. So as kappa is more near to 1, it means your data is more correct. So your confusion matrix s- establishes a kappa. And by kappa, we mean how correct your data is. Okay. How much in Hindi, we will say how much talmel is between your data in the real data and your how much balance is between your real world data to the classified map. Okay. So I hope this was clear now this time. Now, for example, so I have a true color image. If you remember, I created a composite of bands. Okay. So you can also create a composite of bands in false color image. That is FCC. Okay. So based on either true color image or either false color image, you do the classification. So for example, if we are doing the supervised classification, so of this image, I will add some sample signatures. So this is water. Then we take developed. Then I take the forest. Then there is shrubland. So I'm taking all the agriculture land and small plantation in shrubland. Okay. So once I have my four samples, I have divided it into four classes. You can take as many. I will choose here maybe anything that I want in my data. So this is my classified image. Okay. So if you can see this one. So this was the output. So I got a very good output, not a very good one because it classified this area also as water. So these are the pixels from built up, but it classified it as water. Okay. But now I want to create a confusion matrix of this and a kappa statistics of this area to understand it. Okay. So how do I do that? One simple thing is you can just go next, next, next. It will automatically create for it. But to understand by concept, let me first say what you have to do is there is something called as there is a tool in ArcGIS. It is called as create accuracy assessment points. Okay. So this means that we will create some points on this image, some random points, or we will equally place some points. We will create some points on this image, and then we will check on that point if the pixel of the classified image is matching the pixel of the actual ground. Okay. So maybe I will create a point here. So if a point is here, I will know that it is classified wrongly. It should have been built up area, but it has been classified as water. So once you select this create accuracy assessment, you select your output classified image. Okay. Now it has selected the image. Okay. Now there is this thing when you convert this image from the original image, this original image has a digital number at each pixel, right? This has a digital number at each pixel. That is why we are able to look at objects, right? Now, once we classify it, the computer gives it values because wherever you are seeing the same color, for example, if you are seeing green color here, so green color anywhere in this image will have the same value. That is why now they are looking alike, right? Now that is, for example, the value of this green color is 5. So the value of green color everywhere in this image will be 5. The value means nothing actually on ground. The value is just a reference to that color, just a reference to that new class. Okay. So maybe I can say 0, 1, 2, 3, 4, or I can say 10, 20, 30, 40. Okay. So it is kind of a index or something, but you have to just, for the reference of it, you have to give it by default, a value is defined. Okay. Now, That value defined is called in the target field as classified. So there is two values. One value is the ground truth. What it means is on ground it was maybe on ground it was built up area and it is being represented as water. So the built up area's value in this classified map, let us say the built up area's value on this classified map is 20 and for water is 10. Now when I check the data here, if there is a point here and I check the data for that pixel, I will see that on ground it is built up area, not water. So this value of 10 is wrong. I have to assign it 20. I will change it. So that is why here there are two options. One is called classified and another is called ground truth. Okay. So by classified means it will create points here that will have a table classified and it will extract the values from the classified image. Okay. So if you look in the classified image, the attributes of your classified image. So there are two columns, that is value and class value. So mostly value is chosen. Okay. So if I see, if I select this, all of the water is selected. If I select this, all of the developed area is selected. So that means everywhere where there is a developed area, the value is 1. Okay. So the value in this area should have been 1, whereas it is now 0 because it was wrongly classified. So when we choose the create accuracy assessment points, we input our classified image, okay, and then the output accuracy assessment points, target field. Then you have to select the number of random points. So ArcGIS by default tells you how many it should be according to the size of image. So, but to do check 500 points is beyond the scope of time, right? So maybe let us do 10 points. Okay. 10 points is very low. It will not actually be helpful, but for our understanding, we are doing 10 points. More the number of points, more the better the result. Now, there are different methods of placing these points on this image. So if you want it randomly anywhere in this image, we have direct random option. If you want stratified random, that means row by row, 2 pixels or 3 pixels, like number of pixels divided by the rows, but it will be random. It can be here, it can be here, but it will be everywhere. Then there is equalized stratified random. So if it is 50 pixels, it will be equally spread across this image. So this is the best option. Okay. Now once I run it, so also it takes equalized stratified random, it also takes the where the class is present. Okay. So now it has given me 10 points all over. Okay. I think it is 10 points for each class. Yep. Now in these random points, this points has appeared here, right? As a new shape file. Now when I open its attribute table, so I see that, for example, this point, I have to go point by point. So this point has been classified as forest. So the value of forest is 40. Okay. This, it can be seen here only. So this is classified as forest. But on actual ground, now you have to see, is it forest? So you have to write the actual class here. Yes, it is forest. So this value it has picked from here, this class value. Either it can sometimes pick this or it can pick this class value. So it has picked the class value. So 40 means forest. So for example, this point 50, 50 means shrubland. So now you have to check, is this shrubland? No, it is built up area. Now it has been wrongly classified. So uh, built up is 20. So I will say 20. So the total number of points are, yes, 10 in each class. So once you complete this, for example, I'm choosing random only. So the result will be heavily wrong maybe. So you have to go to every point and check which is the real value and which is the wrong value. Okay. So wherever it is right, you have to just select the same value. So once you are done with the ground truth, once you have added the value, you need to save it. Okay. Now I've saved it. So after this, there is another tool in ArcGIS that is called as confusion matrix. That is compute confusion matrix. Okay. Now in the points, you will select these points. So if you remember the total number of pixels from the table, this time it will be total number pixels will be 40 because we did our observation on 40 pixels. So it depends on you how many you can choose. Okay. So I choose these points and it will now create a confusion matrix. So when I run this, a confusion matrix is created. It will be shown on the very end of your contents list. And when I open it, so if you see here on the diagonal, it says class 10, 8 pixels were correctly classified. For class 20, 10 out of 10 pixels were correctly. Here, class 40, That is, you can see the values which is 10, 20, 30, right? So here 7. So, and overall producer accuracy, how much you are near to the ground values is 0.88. Okay. You can calculate uh, from here, you can see the user accuracy, that is 0.85. Okay. And finally, the kappa value. So 0.8 means our data is very good. Okay. Everyone clear about this? Any doubts in this? Okay. So next I was asked, once we classify the image, is there a way to calculate the area? So for example, yes, it is possible to do it in QGIS, but in QGIS it is very lengthy because you have to install some plugins. Okay. So we will do it in future classes, maybe down the line, but you need to install some plugins. Okay. I will tell you which plugins it is. Now, for example, this was the classified image. Now I want to calculate the area that has been classified for each class. And I also want to count the number of pixels. Okay. So there are two ways, one in QGIS, one in ArcGIS. In ArcGIS, there is a built-in tool called as tabulate area. Okay. So once you select tabulate area, it will ask you for the image, classified image that you want to find the area of. Okay. Now we want to have the area based on the value, right? Because the class has been defined on the value. So in this next part also, we'll be selecting the same thing only. Okay. Now, uh, once you run it, you will again get a table. So this time I got a tabular class. So when I open it, you will see, let me also open this. So in this you see for value 0, 0 means water. For water, I have 24,955 pixels in this image. Okay. So since this data was Sentinel image, if you remember, and Sentinel band 2, 3, and 4 is 10 pixel, 10 meters pixel. Okay. So that means the size of the pixel of this image is 10 meters into 10 meters. So 10-meter resolution of Sentinel-2 image. Okay. Now I have 24955 of such pixels. So the area will be, the area of one pixel is 10 into 10, that is 100 into the number of pixels. So when I multiply the number of pixels with 100, it will become this value. Got it? So this area is in meter squares. We can convert it into hectares or something, right? So now we have the total area for water in this image. We have the total area for different classes in this image. Similarly, in QGIS, there is something called as extract by value. So in that, we will put in the uh, extract by value. So, for example, for value 1, if I will extract from this image, it will give me this number of pixels. Then I can find out the area by multiplying it by 100. Now, if this was not Sentinel image, if this was a Landsat image, so what in that case? So, in that case, the area of the pixel would have been, because the resolution of Landsat image is 30 meters, right? So, in that case, the area would have been 30 into 30, that is 900 meter square into this figure. So, that would have been different. Okay. So, it depends on image to image, the area of the pixels. So, we are done with this topic completely. Supervised, unsupervised. Maybe I can show you one example of doing unsupervised also. So, let me take the image and with imagery. So this time I chose unsupervised. Okay. So in unsupervised, it will not ask me about training samples or anything. It will just ask me what number of classes you want. I can say 5, 10, 7, anything. Then it will ask for classifier. So if you remember, there is two popular ones, that is k-means and ISO cluster. So in here we have just ISO cluster. K-means is very difficult. Maybe the company was not able to create a program of it inside of this because it is difficult, right? So we for now we just have ISO cluster. So if I run it, so this is what the computer created by itself. Now this time the name of the classes is not there. It is 0, 1, 2, 3, 4. And I don't like the result because the water and everything is, so that is why supervised classification is much better than the unsupervised. Okay. So we are done with this topic. Anything you want to ask or anything, any question, please? Are all okay? To do in QGIS, there is this thing. Uh, there is this plugin that is called as semi-automatic classification plugin. So we need to install that plugin to be able to do that. I would say it is difficult to do it in QGIS and very easy to do in ArcGIS. Okay. Now there is one small plugin exercise that we can do today. So what I mean is, so sometimes what happens, there is a option in QGIS. So there is an option in QGIS that if you have something in your interface, like you are working on some file and you have created your product. Okay. So uh, maybe let us look at this one only. maybe a new one only. Okay. Now you want to create a web map of it. You want to create a HTML website of that data. So maybe you have your data and you want to present it in the tomorrow's meeting, and you want your data to be dynamically appearing. Now, what it means is you don't, maybe you have a laptop which does not have QGIS and ArcGIS. So you want to prepare a data today that you can put into that computer and you can showcase in your meetings or maybe for some functions. Or maybe if you are a WebGIS developer, so half of your work is done because your shapefiles and everything is directly available to you in that web page. Okay. So it is a kind of a developer tool that is inside of QGIS. So if you go to plugins and manage and install plugin, you need to download QGIS to web. You need to download this plugin. So if you are working along, just download this plugin. Okay. So once you have this plugin in your computer, if you read the instruction here, QGIS plugin to export your project to open layers or a leaflet web map. You can create a web map. It replicates as many aspects of the project it can. No server side software is required. Okay. It is accessible under this title web and then QGIS to web and then create web map. Okay. Now, for example, let me download the data of one of the Indian states. We will go to Diva GIS. So in this website, I will download the administrative boundaries of India. Maybe it's not functional, but we have backup. So once you download this data, it will appear something like this. So it has administrative boundaries of the whole country, the state, districts. Okay. But you cannot use this for official purpose. This is just a reference purpose. Okay. So maybe let me take Indian administration shape 1. So the shape of the head of the India is wrong in this because it is from open source. Now, also let me take the Indian administration shape 2. So these are the districts of India. Now, I have two shape files and I want to do something with them. Okay. First of all, for example, maybe I want to work with Maharashtra. So go to the layer which has the states, right click on it, open the attribute table. In the attribute table, just look for the state. For example, Maharashtra is here. And once I click on this, it will be selected here, right? So in the attribute table, I selected the line and it got selected here. Now, let me export it. So in export, you can save the feature directly. So I will call it Maharashtra and save it to my computer. Something wrong happened here. Export, save selected feature as M1, save only selected features. Yeah. So it took only the selected feature. Now, based on this layer, I want to clip the districts from below. I want to clip the one vector file from another. So, for example, in the processing toolbox, I will select clip. Okay. Now in clip, there is vector overlay. So if one was raster, then we would have chosen this raster extraction. But because both are vector, we will choose uh, clip, or maybe, yes, clip is best. Now the input layer is the one layer that from which you want to cut the things. So the input layer is here, Indian administration 2. Whereas the overlay layer is the extent of which you want to cut. Okay. So in overlay layer, I will choose M1. If you want to save it on your computer, you can just click here and save the file to your computer. And just run it. So if you see now, I've been able to clip my data from that one file. Okay. Now I want to kind of visualize it. I want it to look a little better. So what I will do is in this clipped, I will go to maybe symbology, and in symbology maybe change it to graduated, classify based on ID, and give it a different color. Um, just before we go ahead, I want to ask, have we done creation of population density map? Have I done it with your class? The population density map? Yes. Okay. So similarly, maybe you could create a population density map that would look much better. Uh, Maybe there is some problem. It is not appearing the way it should appear. Anyways, so if you go to this web, there is this QGIS to web. Now, if you want to create, so for example, you did some processing and everything is available and things are opened up here in your interface. Now you can go to this QGIS to web and create a web map. Now in this web map, there is the option of visible pop-ups. So these are the attribute tables of this shapefiles. So every shapefile, for example, clipped and the other one will appear here. So you have to choose which files you want to appear in your web map. Okay. So for example, we choose clipped, and in clipped you can choose how the name should appear. Maybe you can call it Indian name one, always visible. So there are different properties for each attributes, what you want, how it should appear. Okay. Similarly, you have the option to choose layers, which layers you want to be visible. Okay. Mm. Then at the bottom, there are two options, that is leaflet and open layers. These both are open source background maps. So either you can choose leaflet or open layer, no problem. Then there is appearance, the customization of it. Now, if you want the title to appear, how do you want the title to appear? Okay. Layers, collapsed, expanded. So this one is very important. Show pop-ups on hover, highlight on hover maybe. Okay. So you can select based on your, and then you have to export it to your a folder, which you will do it here. So select where your data will be exported and do the export. So if you see, your map has appeared in a web page. Now, if you don't have QGIS or ArcGIS, so you can wherever your folder is downloaded. Okay. So wherever your folder has been downloaded, you can just copy this folder to a pen drive and take it to your new computer. All you need to do is there will be a web page at the end of it, and you just need to click and open it. So if you see, it is dynamic. I can move over it. I can know the values. So however we chose the values, it will appear like this. We can do customization. Okay. Now there is maybe some options. For example, maybe let us in appearance add the geolocate user. Let us add the measure tool. Let us add the address search. Let us add the name search. So there are many things here. So this time it is asking me my location also. So if you were located inside of this, it would have shown your location. Now there is a measure tool this time, right? This you have a measure tool. So in measure tool, you can simply click at one place and know the distance of it from the other place. This is a little unstable when you zoom in. So from one place to another, I am able to find the distance. Okay. Similarly, after measure tool, I have the search tool. So you can search for any elements here. Maybe Amravati. So it has been very zoomed in. That is why when it is zoomed in, it becomes unstable. So also there is option to search feature Amravati. It selected Amravati. So you can do dynamic things in QGIS to web. Okay. Any doubts in this one? uh, then we will try something. So there is this very basic exercise. We have already understood what buffer clip and intersect is. Okay. We have a knowledge of processing box of QGIS now. Now, for example, how to analyze school near flood zone, how to do some spatial analysis. Okay. So, for example, let me take a new project. Let me add the XYZ tile here, or maybe from the quick map service. I will add the Google Earth imagery. Now, let me look for Manali. So, this is Manali. Now, for example, this is my college project or school project. I want to do flood analysis, very basic flood analysis of this area. Okay. So, what can anyone suggest me how they can do it with buffer and intersect or something like that? Does anything comes to anyone's mind? Maybe it can be wrong, but no problem. Maybe if something comes to someone's mind. Okay. So, what happens is, let me create a new vector and let me call it the river. Okay. Geometry type line. Now I will create a river. I will create a river along the actual river. Okay. Mm. Now there is a other part of the river also. So let me say this is my river. So what you can do is we can simply go to overpass turbo and in the Manali area, 20, HPTDC, Potli Gas. So what I mean to say is, for example, you download the buildings data of this area. Okay. You download the schools and buildings of this area. Okay. So when there is a river, what is the first thing that happens when a flood comes? So you will mark a zone that will define that how much area is a risk zone. Okay. So for example, if you say you go to your processing toolbar and you look for the tool buffer. Okay. So in buffer, you say my input layer is river and you say uh, maybe 5 meters is your buffer. Let us try this if it works. Yeah. So it creates a buffer of, maybe it created a buffer of 50 meters. Okay. So 50 meters, it is 5 meters only. So this is the highest risk zone. Okay. So if someone wants a risk zone of the flood map, this is the highest risk zone. Now, if you want to create two more zones, maybe that is 100 and then is 150. Okay. So, for example, if now you take, uh, you say 10 meters or 100 meters. So, this zone, if I take it above this, now This zone is a moderate flood risk zone. This is high risk zone. This is moderate flood risk zone. Okay. And then maybe you can create one low risk zone also. So you have three zones here: high risk, moderate risk, low risk. Now I want, because this is a complete file, I want to calculate the area that belongs to that particular zone. Okay. But how will I do that? Because this is not this big. This should have been this, this one minus this one. So, do you remember there was in overlays, there was something called as, there was this tool called as erase, right? So we will look for erase. So in erase, uh, we will take maybe the, it is not different named. Need to name it differently. Okay. So for example, uh, my input layer is buffer 3 and I want to erase the layer buffer 2 from it. Okay. Buffer 3. Thing came out. Buffer 2, buffer 3. So I subtracted from buffer 3 the buffer 2 layer, and this was the difference. Now I have the uh, now I have the lower risk zone. I have defined it. Okay. Similarly for this also I can subtract and create three zones. So you can see you can create three different zones and you can calculate the area then. Now, what if there was some, so let me assume that there are some schools here. Okay. So we create a file, we call it schools. Should have made schools when I made rivers. Okay. So I create some points What has happened to it? Got hanged. It got hanged. But basically, what I wanted to show you was I was creating some schools and we could find it out that the schools are in which zone, low risk zone, high risk zone, based on the flood levels that we created from the buffer of the river. Okay. So I will end the class today. If anyone has any doubts about whatever we did today, okay then. Sir, is it possible to use real data of flood detection and real SHP river? Yeah, for example, you have to look for the source to find the river data. For example, in Earth Explorer, Earth Explorer is not working. I would have shown you how to download the river data. Okay. So just select the region where you want to download the river data and use map. So I want to download the river data of this region, then datasets. And in the digital elevation, I have this option of SRTM water body data. In digital elevation, I have the SRTM water body data. So because this survey was done very, very long back, so the data is from 2002. So if you want very, how to say, recent data, you have to look for the sources where you can find the recent data. So for example, if I, so this data is from this region, that is, it will cover this river, and maybe this is from here. Okay, let this is let me download this data. So the buildings you can take from OpenStreetMap, right? And the rivers you can find from data like this one. What is this? Not correct. So for example, this is for this I downloaded before. This is for this region. Okay. So this is the actual flow of the river. This is the polygon of the river. So you can create a center line. There are tools to create center line. Center. Uh, in ArcGIS, you have something called as center line. Here it may be called as centroid line or something. We will have to look for it. But you can download the whole river polygon of the area and you can do the analysis. Okay. Okay, then guys, we will meet tomorrow. If any doubts, you can just connect to me. Okay, then take care.